Welcome everyone to BTT 151, Fundamentals of Electricity. Would like to introduce Unit 5 concepts. Unit 5 is on series circuit. So what we're going to learn as we study Unit 5, a series electrical circuit is one in which the resistors are connected together. The current will remain the same through each of the resistors, but what we're going to learn, what we call voltage drops, the voltage drops across each of those resistors will add up to what the overall supply voltage will be, or in our case, the battery voltage. Also, we're going to learn the power supplied by the electrical circuit is going to be equal to the power that is dissipated by each of those resistors. So what I've prepared is a standard schematic diagram for a series circuit where we have a battery with voltage V, and then I have two resistors in the circuit, resistor R1 and resistor R2. I've set up a direction of current flow using conventional current flow where we leave the positive post of the battery, go through each of those resistors R1 and R2, and then return back to the negative post of the battery. So I've written down all of the steps that are required to solve a series circuit. So the first step we're going to take a look at is solving for what's called REQ, which is the equivalent value of resistors in series. When you have resistors connected in a series configuration, you simply add up the values. In our example here, there are only two resistors, so it would be just R1, the value of R1, plus the value of R2. If you had four resistors, for example, it would just be R1 plus R2 plus R3 plus R4. The second step to remember, the current remains the same everywhere in a series circuit. So the current that flows through resistor 1 is equal to the current that flows through resistor 2. The third step to keep in mind, what we call the sum of the voltage drops will equal the voltage supply in the circuit. So the voltage supply in the circuit is the battery voltage V, and since we only have two resistors in this circuit, there's going to be a voltage drop that we call VR1 across the first resistor, and there's going to be a voltage drop that we call VR2 across the second resistor. So we simply add up the value of VR1 plus the value of VR2, and that should equal whatever that battery voltage is. The fourth step, the power supplied by this circuit is going to be equal to the voltage multiplied by the current. And then the last step, there's going to be two sets of powers that are dissipated because we have two resistors, R1 and R2. So we're going to find a power dissipated at resistor 1, and we're going to find a power dissipated at resistor 2. When we add up PR1 plus PR2, that is going to be equal to the value of power supplied by a circuit. So again, as we solve series circuits problems in Unit 5, what again to always keep in mind, the current is the same in a series circuit. The sum of the voltage drops, in other words, that voltage dropped across each resistor has to add up to the battery voltage. The power supplied is going to be equal to the power dissipated by each of those resistances. So please read Unit 5 in your text, view the PowerPoint presentation, and additionally I have a video on series circuits and how to work with series circuits. So have a great week. We'll see you next week. Thank you.